Okay, hello everyone. In this video we're going to be looking at forces and accelerations. So I'm going to present four different scenarios here where we have a block on a surface and we want to actually know for which situations could the block be stationary or traveling with a constant velocity. So I'm going to go through and explain some of these. So first off, I guess it's a given for each situation, but because we have a surface and the block obviously has some weight, mg, we know that there's obviously going to be an opposing normal force in the opposite direction, because based on Newton's third law, every action has an equal and opposite reaction. So we're just going to ignore those because we assume that they obviously are going to be equal in magnitude. But what we essentially need to do is use Newton's second law when considering this problem. And that is that we have, in order to get accelerations, force equaling mass times acceleration. So there must be some external force for an acceleration to occur. And we know this based on Newton's first law. The net force must equate to zero in both dimensions for an object to be stationary or moving with constant velocity. Because if we have a net force, then the object is accelerating. So it can't be stationary, it can't be moving at a constant velocity. So when we're asked to find these objects and whether they can be stationary or at a constant velocity, we're essentially seeing whether or not a net force could act on the objects. So that's a key thing to keep in mind. It's something you really need to get your head around because it's very important. So if we have a look here, what we have is we have F2 in the x direction. And what we really need to do is we need to consider the net force in both directions. That's the key thing with these problems. So we have some component in the x direction here as well. So potentially our net force in the x direction could be zero because these are in opposite directions. They could cancel out each other because they're both acting on the same body. In terms of the y direction, we still have a y component here from the F1 force, which we can resolve. We've essentially resolved this vector into orthogonal components. And from this we can see, no, there's nothing to cancel it out, because the normal force and the gravitational force are both balancing each other. So what we actually have here is a actual force in the y direction that's unbalanced. So the net force in the y direction, or the y dimension, is not equal to zero. And as such, this object cannot be stationary and it cannot be traveling with constant velocity. It must be accelerating because a net force is acting on it in the y direction. There's nothing to balance this out in the other direction, so we have a force and an acceleration acting in that y direction. Number two is a bit more straightforward. Again, we can assume that we have a normal force acting, so it's sliding across the surface, but those two are going to balance anyway. So now we just need to look at essentially just the x direction because there's no other forces in the y direction. And this is moving in the x direction and this is moving in the opposite direction in the negative x direction. So from there we could say, well, the forces could potentially cancel. And if the forces cancel, there's no net external force acting on the object. So based on that law, we can say that it is possible that this object is stationary or traveling with a constant velocity. Okay, and now let's have a look at the third situation. So again, we know we have the normal force and the gravitational force because it's on a surface, but we don't need to worry about them. So let's have a look in the x direction. In the x direction we have this, and we also have a component of the F1 vector. So it is potentially possible, because this is in the opposite direction to that force, that these forces do cancel and the net force in the x direction is zero. But let's have a look at the y direction. The y direction, we've got the force F3 and we've also got the force F1. Both of them are acting upward and there's nothing to cancel them out downward, because remember, the gravitational force is being used up by the normal force. So those two cancel each other out. So as a result of that, we know, hang on, we're going to have some acceleration in the y direction because our forces do not cancel. So as a result, this object is accelerating. Excuse my poor handwriting. So now let's have a look at the fourth scenario. So if I just move down here, we can see, well, okay, there's going to be obviously the gravitational force, and we're going to have the normal force, which is just equal to negative because the direction, what's the magnitude of the gravitational force. So let's have a look in the x dimension. Again, we have something there, and F1 has some x component. So as a result, these two could potentially balance because they're in opposite directions. Then what we have is we have some y component of F1, and then F3 is essentially just all the y component, and because they're in opposite directions, they could potentially cancel out to make the net force equal to 0. So as a result, we could say, yes, this object could potentially be stationary or traveling with a constant velocity because the net forces in both directions could potentially cancel out, so there's no net force acting on the object, and therefore, based on Newton's second law, no acceleration. So that's a good way just to think about this conceptually. Remember, forces, you have two directions you essentially need to survey. So remember to look at the x and y direction, unless you're looking at 3 dimensions, but again, generally you're going to come across 2-dimensional problems such as this. So hopefully this video was helpful. Leave any comments below. Thank you for watching.